Let's do example B. Now, what I want to point out is they're saying that this is a challenge. And let's have a look as to why they deem it as a challenge. So what you see is we've got 9x plus 3x minus 2 divided by 9x minus 4. Now, I always tell you I want things in my prime bases, right? Which is just going to make life so much easier. So what are we going to prime? We're going to prime the 9. 3 is prime, 2 is prime. We're going to prime the 9 and we're going to prime the 2. Is that sensible to you? Okay, let's see what we can do here. So let's just do prime places. 9 is 3 squared, and that is to the power of x plus 3 to the power of x minus 2 divided by 9 is 3 squared to the power of x to the power of 2. So it's 2 to the power of 2 to the power of 2. No, I wrote it. I'm reading wrong. That bottom one should be to the power of x. Minus 4 is 2 squared, and that is by itself. Now, the reason why this is deemed a challenge is because now the question is, what do you have? So let's simplify this one. If we multiply, we're going to multiply power to power, power to power. That's the only part that we're going to change. So we're going to have 3 to the power of 2x plus 3 to the power of x minus 2 divided by 3 to the power of 2x minus 2 to the power of 2. If you're looking at your exponents alone, there is, I'm going to write in yellow, this is x, 0x, 0x. This is 1x. So you have 2, 1, 0. If your exponents go 2, 1, 0, this is a trinomial. Okay? A quadratic. Okay, which means we're going to factorize as if we're factorizing a quadratic. Whereas at the bottom, we have 3. If you ignore the x, you have 3 squared and 2 squared, which means we have difference of 2 squared because there's a subtraction in between. And that identifying the situation that you have is the thing that makes it important for you to be able to see what you're dealing with and determine based on what you see, decide what you're going to do. So what we can do is we can change something. We can use the K method and we can make a statement and say let 3 to the power of x equal K. This is the K method. You are telling the reader, okay, this is complicated. I'm going to use substitution to make it easier to read. Can you see 3 to the power of x? So that 3 to the power of x, we're going to make K. And what's left on that K as an exponent is 2. Now I have K squared. Plus 3 to the power of x, that's K, minus 2, divided by 3 to the power of 2x. Now I want to take away that yellow line before you think it's actually there. 3 to the power of 2x. We're going to say 3 to the power of x is K. And what is left? Squared. Minus 2 squared. Now, is this easier to see as a quadratic over difference of 2 squares? Okay, now we're going to factorize. What are the factors of the first term? Okay, our numerator is going to become K times K gives me K squared. And the only factors of 2 is 2 and 1. Now, I want a positive 1 as an answer. So 1 times 1 or K times K and 2 times 1. Now, when we add and subtract, we want positive 1. When we multiply, we want positive 1 and negative 2 when we multiply. So let's see. If we do cross multiplication, let's go green this time. That gives me 1 and that gives me 2. If I add or subtract, I am going to get 1 or 3, right? Add it, I get 3. Subtract it, I get 1. I want 1. which means I want to subtract. I want 1. So what am I subtracting from what? I want positive 1. So plus 2 minus 1 gives me plus 1. This sign over here goes in the middle, k plus 2. And this sign over here goes in the middle, k minus 1. Okay, my numerator looks like that. My denominator, we're doing difference of two squares. Difference of two squares is two brackets with a plus and a minus. K over here, 2 over here, 2 over here. I am happy with that. All good. All right. Next up, I have simplified, but I need to go back. Remember where I said let 3x equals k? Now I'm going to go back and I'm going to change k back to 3 to the power of x. That's what we're going to do now. So every time I see k, I'm going to put in 3 to the power of x. So I'm going to have two brackets on the numerator and I'm going to have two brackets on the denominator. Every time I see k, I'm skipping it because I want to change that to something else. Actually, we can cancel first if you want, or you can cancel after. So k becomes 3x, 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 3x. Every time I see k, I make it 3x. Okay, so what was I talking about canceling? You can cancel, these two are identical. You can cancel here, or you can cancel here. Those are exactly the same. What does this mean? It means what you're left with is 3 to the power of x minus 1 divided by 3 to the power of x minus 2. What is your final answer for this? It is 3x minus 1 over 3x minus 2. That is your final answer.